Hello, everyone. So how does this work? Do I speak, I pause, you translate, or? Oh, there's no translation. There is. There is no translation. Okay. No, that's fine. But so I can speak fast, or can I slow? Slow. If I start to speak too fast, please let me know, and I'll probably continue to speak fast. Because I don't do it on purpose. It comes naturally. Okay, so welcome. Thank you for coming. And I'm going to give you a very short presentation here because there isn't much to talk about when it comes to DSLs in terms of Kotlin. I mean, there's a few things that you can learn and use these concepts. But to just get everyone on the same page, I'll review a little bit of the syntax and then build up on that. So I assume that this is the Kotlin user group, which means that everybody here is doing Kotlin? Everyone? Okay. So, right, that's good then. So, why am I giving a presentations on DSL if everyone's doing Kotlin? You know how to do this stuff. Okay, well, fine. Let's repeat what we know. I've also got a talk on functional programming. If you want, we can switch. Up to you. Anyway, so we know how to write functions, right? That's very easy. X plus Y. Yay. Next. The next thing is we're all also familiar with the concept of extension functions, right? So, for instance, I can say is same as value string, and then this, also do it as a single expression function, say this equals value, right? Where this is the instance of the extension function and then value. This is a syntax that we use quite a bit, which is the single expression function, and you can actually express any function with a single expression that even fits on one line. If you ever have a problem, usually you just buy a 4K monitor, then there is no problem. Okay? So now I can call, string is same as another string. And the nice thing about this is that then you can extend this to make it infix notation, right? So instead of calling it in this way, I can call it in that way, right? By making the function infix. So this opens up the ability to have a little bit of a nicer syntax when it comes to Kotlin. And this even becomes nicer when, for instance, if you're familiar with an assertion framework, a testing framework called Kotlin Test, it does things like this. It says, for instance, it creates a function called fun, let's say on a generic type, or we'll just say, for example, a string for now should be value, right? This equals value, and if not, throw a assertion error, right? So, this would be if value equals this, then good, or if not, then throw assertion error does not match. So you can start to create nice little assertions using this kind of syntax, right? Because I could say now string should be another value. Now the beauty of this comes in when I can start to also not just have one infix notation, but start to concatenate things, right? So now I could have one thing concatenated with another thing, concatenated with another thing, and lead towards, a string of, or a line of different elements, all of them concatenated using this infix notation, right? So, for instance, how many of you here do functional programming? You write functions, don't you? No, I'm joking. That's so here, for instance, you see that I'm using this concatenation for that purpose, right? I have a function that is, are you familiar with a library called arrow? Generally, my questions are really simple. They're just yes or no. There is a library called arrow, right? You go to arrow.kt, and if you're not familiar, I recommend you take a look at it. It adds some functional things. Back in the old days, there used to be a library called functional, spelled with a K. Then there was another library called category, spelled with a K, because apparently it was in fashion that anybody that does anything for Kotlin replaces the C for a K, and if there is no C in the word, they'll just replace any other letter for K. And they joined forces and made a single library which is called Arrow. And Arrow adds a few nice things to your standard library, such as, for instance, option or try. These are nice little things that allow you to create functions that either throw an exception or return a value. And one of the things it also adds is function composition. So here, for instance, I have 3 lambdas, right? The first one over here, second one, and the third one. Now, if I wanted to create a function that does all 3 things, what would I have to do? I would have to create a function and then call one after another, assigning the values and pipelining them through. What you can do with functional composition is actually just compose the functions. As long as the condition that one function takes an A and returns a B, the second function that you want to compose with has to take the same input type, I can start to compose. So you see that here I'm starting to compose multiple functions using the same thing that I just showed you in terms of infix notation. So you can start to chain these things, right? Compose is nothing more than an infix function that takes some parameters. Okay? So these are one thing that we have in Kotlin to try and be more expressive. And why am I even talking about this? Because everybody here is familiar with the concept of a DSL, right? Domain-specific language, right? A DSL is a language that is specific to a particular domain. Do you like how I explain things? I just turn the words around, right? Domain-specific language is a language that's specific to a particular domain. and I sound like I know what I'm talking about. The idea here is that you try and create a language that is specific to some type of business domain or whatever you're doing. And there's 2 types of DSLs. There are the external DSLs, which are outside of the scope of the main language. And then there's internal DSLs, which can be combined with your main programming language. So Kotlin is very great at doing the internal DSLs. And I want to emphasize here that a lot of times when we talk about DSLs, people think that this is not needed. Like, I don't need to know about DSLs because I'm not going to create a new language. Like, I'm not going to go and create a new version of HTML. And I beg of you, don't do that. It's already done, and it's called Markdown, okay? But you can start to use these DSLs for small things in your applications. That's where the beauty of DSLs comes. How many of you are familiar with the concept of domain-driven design? So domain-driven design is popularized by a fellow called Eric Evans, and in it he was talking about how we try and align the code that we write, the architectures that we do, align that to the actual business needs beyond just the simple analysis that we do. And one of the things that he was talking about was this concept of a ubiquitous language, which means that I express in my code terminology that is exactly the same as it would be in my business domain. To give you an example, let's say that you're doing a system for invoicing, right? Every invoice, every country has value-added tax. So instead of me writing a function that is called calculate percentage. And then I'll say this is a very nice generic function because I can pass in a value for tax, I can pass in a value for deductions or whatever. I would be more specific and I would say calculate sales tax, right? And start to make my language make my code mimic exactly the language that my business people are speaking. But when we look at functions, when we look at code like this, it ends up in a situation where we have all of this noise, like fun, brackets, all of these things that get in the way. So if someone from the business domain, for example, looks at this, says, I don't really understand what's going on here. I'm trying to understand the code to see if you've reflected properly what my business intentions are, but there's too much noise because I don't know how to write Kotlin, okay, or the Java language or whatever. So this is where this aspects of DSLs in Kotlin can come useful. And we'll start with something very simple. So let's say that I have a class that's we're going to call, for instance, a course, and that course has a title. I'm going to give it a name, title, string, and empty that to empty string, and it has a description, string, and it also has, let's say, for example, an instructor. So I have an instructor here, and that would be instructor, right? And we're going to initialize that to empty instructor as well. So let's go ahead and do instructor. Okay, so now I'm going to create a class instructor2, which is going to have a name and an email, and empty those up. Okay, so now I've got my course and my instructor. Now I want to create an instance of this. So what would we usually do? We would do val course equals course, and then of course I could pass in the parameters, but let's say that I want to configure it later on, just like you do, for instance, in a view in Android. Everybody does Android here, right? Is there anybody that doesn't do Android? Me. I actually don't do Android. But please, don't hold it against me. I don't do iOS either. It's just I don't do mobile development. So Kotlin DSLs, and then we do course description, a course on Kotlin DSLs, and then we're going to do course instructor, and then here I would do name equals me, and course instructor email equals me@gmail.com. Okay? Now, this is what? This is pain because I'm repeating course over and over again. So there's a nicer way to write this. In Kotlin, what you can do, if you're not aware, there is a with. Everybody knows about the with function? Which with essentially says, with course, do something. So now I can get rid of this, bring it up, clean it up, and then let's take a look at, take the course. Right? There you go. Now I have my course configured without having to write the with. And I could do the same thing here. I could do with instructor and then do pretty much the same thing. Right? And get rid of instructor. Okay? Now, that is nice. There's actually a quicker way to do this, even if you don't want to have an instance of course. You could also do something like course apply, and then here write title something. Okay, and remember this because we'll use this, right? So yes, this does allow me to get rid of some boilerplate in terms of course. However, there is still the noise, and the noise is, for example, this with and this with over here. And what I would like is to do something like this, right? That looks much nicer. In fact, it looks like JSON, right? I'm not saying JSON is good. I'm saying it looks like JSON. Actually, JSON is probably the only good thing that came out of JavaScript. So what am I doing here? Let's try and analyze what we're doing here. First of all, let's get rid of this course. So what am I doing here? This is something with something. This something, you're all familiar with what it is, right? This is a what? A lambda. Yes. And this is, so this is basically a higher order function. Course could be a higher order function, right? So I can do something like fun, course, and then take a lambda, right? By the way, want to see something very, very cool? This is the coolest thing you're going to see today, right? That's the character for function that you can invoke using Alt F. And now if you tap it, you get a nice lambda. Huh? Whoa! That's like very cool. That was like one day I was doing a webinar with one of my fans. I'm his fan, Eric Meyer, who's from C# fame, and he was the moderator. And I was giving a webinar on Kotlin at home. And when you do a webinar, there's no audience, right? So I'm giving a webinar and I'm talking, no questions. 50 minutes in, Eric says to me, "We have a question." I'm like, "Yes, finally. What is the question, Eric?" And he says, "Someone is asking how you get that arrow in IntelliJ." So I talk for 50 minutes on Kotlin, and they want to know how to get an arrow in IntelliJ. Okay? So I have this course. Now, what can I pass in as course? So let's look at this. This is title, description, and instructor. So what I want to do is basically pass in these properties. So in principle, if I pass in a course, given that there is a convention in Kotlin that allows me to refer to a lambda with a single parameter as it, I could potentially end up in a situation like this, which is nice, except it's not nice because it's got an it in it, right? So I don't want this it. So how can I get rid of this it? This is a higher order function that takes a function. We also have in Kotlin another type of function which is called an extension function. So let's pass in an extension function as opposed to a regular function. So I'll now pass in an extension function, right? Which is represented in this way. It's the name of the type and then dot and then the parameters of the extension function. In this case, none. As soon as I do that, voila, now I have my beautiful little DSL coming into shape. Now let's take a look at this one. Now this one you could say, well, this is a function as well. It is a function, but in this case, it's not a function because it is an instance. It's an object. So how can I do the same thing here? Well, if we analyze what we're doing, essentially here what I'm doing is what? I'm trying to invoke that function. Sorry, invoke that instance. And I'm sure that you know that it's possible to do that in Kotlin. So I can have, for example, a class Q, right? And then I could come here and write foo. By the way, do you know why you should never name your variables foo? This is a true story. Two friends of mine were giving a presentation once. One of them is an English guy called Richard. The other one is a German guy with a very strong German accent, talking on stage, and Richard is typing. He's the code monkey. And so Christian is on stage, and they're explaining MSMQ, which is queuing technology. And Christian says to Richard, he says, "Richard, create a queue for me." So Richard creates a variable called foo queue, right? And Christian on stage is saying, so now we have this foo queue. And then he says, oh, Richard, create another queue for me. So what does Richard do? Creates a foo queue too. And that's why you should never name things foo. So here I have queue. Now what I want to do is queue something, right? How can I do this? You press Alt Enter. You see, you don't even need to know Kotlin. You just need to know Alt Enter. And what this does is essentially, as you know, in Kotlin, you can override certain operators, right? You can't take any symbol and create an operator out of it, but certain operators you can by convention. One of them is invoke. As soon as I create an invoke, I can then invoke my instance, right? So if I can do that there, let me do the same thing here. So I'm going to go ahead and create a... See? This is what happens when I say, I say press Alt Enter and now it doesn't work. So here, and in this case, what do I need? So let's go back to my DSL. What am I doing? I am passing in, again, the parameters to, in this case, instructor. Therefore, this has to be an extension function to instructor that returns unit. Okay? So you see that now I get my nice little DSL. Okay? By the way, I said returns unit because that's the correct thing. Unit is a value. It's an object, right? Do you know how you express a function that doesn't return anything? Nothing? Who said nothing? Nothing. You say nothing, right? Nothing is a type in Kotlin. It's at the very bottom of the type system, right? If you navigate to nothing, you get a class called nothing with a private constructor. If anyone ever asks you what's at the bottom of the Kotlin type system, you can say nothing. Even if you don't know, you'll get it right. So now, can anybody tell me what the issue is here? This looks good, but there is a problem. This, right? A, I have to initialize it. I don't like to do that. B, it's var. Okay, var is evil. In fact, that's why it's underlined. Like, we don't enforce immutability. We do something worse. We annoy developers. How do you annoy a developer? You underline their code, right? That is actually a true story. That is why we underline this, so that people get annoyed and they're like, oh, I don't like this. Okay, then create a val. It's gone, right? So what I want to do is get rid of all of this. Get rid of all of this nonsense over here. And now I've got this, and I'm going to get rid of the same thing over here. I don't like this stuff. Right? But the problem is that now I can't actually initialize. But you can do that. There's a pattern for it. It's called a builder. Right? So I could create a class that's called a course builder. And this course builder has a property that is title of type string and a property description of type string and a property instructor of type instructor. Okay? I could just initialize it. Now, and this one, we will do the same thing. We'll just empty that for now. Okay? And then I can create a function called build that what it does is it returns what? It's going to return a course with title, description, and instructor. So now I can build a course. So here, instead of having a course, instead of passing a course, what I will do is pass a course builder, right? And the implementation of this, if you're wondering, is basically just course builder, apply the Lambda block. Remember how I showed you how you can apply properties, and then call build. Very simple implementation. And then automatically, I've got this now without having to have them as vars as part of the course. So I can use that course class without having this mutable property as such, and at the same time get my nice looking DSL, right? And for the instructor, I would do pretty much the same pattern. I would create a class which is the Instructor Builder. And then here again, I would have the name. I would have the email. and then I would have the build function that would return the instructor with name and email. And then much the same way in the, where are we? Here, instead of the instructor, I would have the instructor builder. Okay? Right? So on and so forth. And then you can extend this and add, for example, collections, right? And have collections and have multiple elements, etc., etc. But there is still one problem, because one of the good things about creating DSLs using Kotlin is that, contrary to some other languages, like for instance Groovy, right? Gradle, you all use Gradle, whether you love it or hate it, you have to use it. One of the issues with Gradle is that, of course, it's, you know, well, I mean, if you're using Gradle with Groovy, you have to read 65 chapters of the Gradle documentation and then go to Stack Overflow and figure out how to do something, right? And then it doesn't help either that it's dynamic, so now I can basically put anything anywhere. With Kotlin, it's not the case, because I get completion, and here I say title, and it's absolutely fine, right? And then I can come and say instructor, and inside instructor, I write name, and it's absolutely fine. And then I come and say, oh, and I get title. Like, oh! So the problem here is this. We don't want this to be possible. And there's a way that you can solve that. There's actually an annotation. You can create an annotation class that I can call, for example, course DSL, right? And then decorate this annotation with a DSL marker, okay? And then any class that is part of my DSL, I say DSL marker. So here, sorry, not DSL marker, course DSL, right? So I have course DSL, and I have course DSL here. And now, where are we? And course DSL. Hold on a second. I've got it on the instructor. I've got it on the thingy. I have got it on. I don't need it there. So what I'm going to do is leave. I'm going to leave this as an exercise. Hold on a second. DSL marker, I've got it on the annotation, I've got it on the instructor, I've got it on the course. Instructor Builder, yes, there, where? That's the one that I should, there you go, yes. I don't actually have to have it on the course. I don't think I need it here. Yes, correct. There you go, well done, thank you. So there now, you see that title is no longer applicable in that context. Right? You can still reference that title by doing explicit this at course, which then refers to the actual instance of the Lambda that's being passed in, but it doesn't give you that out of the box. Okay? So now, you know, I've done an example where I've taken a course and a title. You imagine now that you can change this to say, for example, you know, taxing, you know, percent and evasion. No, not evasion. I'm from Spain. Everyone tries to evade taxes. Not me. Anyway, so, you know, this now leads to a situation where I can actually start to create my own kind of language for my business domain. Now, take this idea and combine it with the ability that Kotlin allows you to have scripting. Are you familiar with scripting? You can take a file with the extension .kts and essentially have script, just like the Gradle DSL. And if you're not familiar with it, tomorrow I'm going to publish the Talking Kotlin episode exactly around scripting. So listen to it. So what I can now do is take that and potentially have people that aren't developers write DSLs that then I could use in my application. Whether I'm loading that dynamically or whether I'm making it as part of code generation and compiling it into the application. Okay? So essentially, there's very few things in Kotlin that allow you to create this kind of syntax. One of them is the infix notation, extension functions, the ability to invoke instances, and this thing over here, which I haven't told you the name, which is called the Lambda with receiver, right? Because it's a Lambda that has a receiver. And since no other language has this concept, we coined the term Lambda with receiver, right? So it's just these things and the ability, the convention that the last parameter to a function, if it is a function, can be outside of the brackets. These 3 or 4 characteristics of Kotlin is what allows you to create these nice DSLs that you can use for different aspects of your application. That doesn't have to be, I'm going to create a completely new language, but focused around different areas of your application. Okay? That's it. And I think I'm on time, right? Yes. Excellent. Look at that. I timed it perfectly. Yeah. Thank you.